So we're going to kind of move away from algebraic stuff and talk about functions, but first, before we talk about functions, we got to talk about a relation. So a relation is just a correspondence between two sets. So I'm going to have two sets here, and a relation is just where I kind of match up things from one set to another set. So as an example, let's say that I have people over here, and I have their heights over here. So I have person 1, person 2, person 3, person 4, and person 5, and these are going to be in inches. So how about 63 inches, 69 inches, and 72 inches. So a relation is just where I correspond the two. So I'm going to say that person 5 is 69 inches, person 4 is 72, person 2 is 63, person 3 is 69, and person 1 is 63. So that's a relation. A relation is just two sets that have some sort of correspondence between the two. A little bit of notation here. We can write that person 1 was 63 inches this way, or we could write person 1 was 63 inches that way. So we're going to say this set are inputs, this set are outputs, and this is how we're going to write it. So it's always going to be input, output, input, output. Now a function is a relation, so I'm going to have two different sets here. Typically we call this a capital X and a capital Y. A function is a relation, but you can't have this happening. So I can't have, let's say this is my first, this is my second, this is my third, and over here I have, how about an alpha, a beta, and a gamma. You can't have the same element being mapped to two different things. That's not a function. So this is bad. Whenever you see an element over here in X being mapped to two different things, that's not a function. Now, what we can do is if I erase this, it's fine to have this happening. So it's fine to have two X values being mapped to the same Y value. That's fine for a function. You just can't have, one here mapping to two different things in Y. That's not a function. So let's write down that definition. So a function. A function is a relation that associates with each element in X exactly one element in Y. And it's exactly that same picture. So I have my X here, I have my Y here. For any element I choose, so let's say I have X1, X2, and X3, and over here I'll have Y1, Y2, Y3, and Y4. For any element I choose over here in X, it's only allowed to be mapped to one different Y, or one Y, no more than one Y. I can only map X1 to one of the Y's, doesn't matter which one, and I can only map X2 to one of the Y's. You can't have this, I can't have X1 going to Y2 and also Y1, you can't do that. So that's a function. So for example, is this a function? So a little notation here, let's see, I'm going to have 1, 2, 2, 3, 4, 0, and 1, 5. Is this a function? Keeping in mind the notation here is input, comma, output. So let's see. 1 mapped to 2, 2 mapped to 3, 4 mapped to 0, but also 1 mapped to 5. As soon as you see that the same X mapped to two different Y's, this is not a function. You can't have that happen. You can't have the same X value mapping to two different Y values. What about this one? How about 1, 1, 2, 1, 3, 1, and 4, 1. Is this a function? Let's see, 1 mapped to 1, 2 mapped to 1, 3 mapped to 1, and 4 mapped to 1. Is there any problem with that? No. All of my x values are different, so it's fine. So this is a function. So just remember, for a function, you can't have x mapping to two different y values. That doesn't work for a function. Notation-wise, a function is typically going to be f of x and then equals something. Let's say 3x minus 2. The way you want to read this is not to say f times x. That's not what this means. This means that x is your input, and here's what to do with it. So think of f as a machine. It's a function, but it's also a machine. It takes something, so you take your input, it does something to it, that's this part, and then it's going to spit out an output. So in our example, let's figure out what's f of 1. So this says that my input is 1. I want to know what's the output. So the output should be 3 times 1 minus 2, because that's what the machine told us to do. It said to multiply by 3 and then subtract 2, so I get 1. What about f of negative 2? So look at what the machine says to do. It says take it negative 2, multiply it by 3, and subtract 2. So that's going to be what, negative 8? And what about f of 0? So this says my input is 0, I'm going to multiply it by 3 and subtract 2. Now what does all this mean in terms of coordinates? That means that I have 3 coordinates. 1, 1, so there's my 1, 1. Remember, we always write the input first. Negative 2, negative 8, and 0, negative 2. So all of those are inputs and outputs of this function. So for a function, we're going to have inputs, outputs. The way we write them is as ordered pairs. So it's always going to be input, comma, output.